Welcome to the world of mathematics. The topic that we are going to discuss today is the cost of Gauss elimination and the Gauss-Jordan elimination method. So let's see. Let's start. Let Ax is equal to B be linear system of n equation with n unknown to be solved that we need to solve by using Gauss-Jordan elimination or equivalently Gauss elimination with back substitution. Okay. Now more what we are assuming for simplicity, let's assume that A be invertible matrix. That means it's not singular and no interchange of rows are required in the augmented matrix in the row echelon form. Okay. Another thing, the diagram that I have shown below accompanies the following analysis, provide a convenient way of counting the operation. So what those things are there? Number one, we required to introduce 1 in the leading first row and then 0 below it. That I have done here in the below. Then in the pivot element we have introduced 1. Okay. In our operation, okay, in operation counts, we will lump division and multiplication together and we call them multiplications. Similarly, we call additions and subtraction, we lump together and we call them additions, right? Two important formulas that we will use here that I have already written, they are what? They are these. The sum of first natural number is n into n plus 1 upon 2 and the sum of the square of first natural number is n plus 1 into 2n plus 1 upon 6. Okay, you should know these two formulas. Right, now come on the calculation. Now in starting, I am assuming that this is our matrix, okay, and by n matrix, and this matrix what I have assumed dot denotes the quantity that is not being calculated. Now this matrix is n by n, okay, because I have added one more column, that's why its order has become n rows with n plus 1 column. Okay, so this thing I have written here, the size of matrix is n by n plus 1. Okay. Now remember from the Gauss-Jordan method, what do we need to do? We need to get one here. Okay. We need to get one here. Then to get one here, what do we need to do? Over there we divide this element. For example, this element is 1 1. Then we divide this 1 1 with the all first row, also with this one, also with this one, also with this one, all the way up to the also with this one. Okay, so in this case, how many multiplication I should say rather than sign division? So how many multiplication do I need to use here? I need to use n multiplications. Okay, you might think there are n plus 1 columns, so why do we need n multiplications? Because computer knows already that first entry is going to be 1. So it does not divide. You can think it does not divide. We can save our one flopping point. We just computer, what does computer do? It just type 1 here and it divides all the other elements by this element, that is a11. Okay, so what do we need? So how many flops did we use here? We use here n flops as a n multiplications, right? Okay, now again let me go to the next step. Now after doing this, what do we need to do? We need to introduce 0 below this column. Okay, now again we have to store our flopping points. So computer knows that the below of this row, what I have to type, I have to type zeros. So computer does not count this column. Okay, computer, what does the computer do? It only recognizes this entry. For example, this entry is what? This entry is, for example, let me it's a second row first column. Okay, what does the computer do? Computer multiplies second row first column entries with what? Row 1. Okay, then the negative of this one, then adds with what? Then adds with R2, and we get the new, sorry, it's R2, my mistake, R2, then we get new R2. Okay, now just tell me how many multiplication did we need here? Just think about it. Okay, how many elements are there? So how many multiplication did we need here, and how many additions also did we need here? You have to think about it. So when you focus here, the number of elements, how many columns are there? There are n columns remaining, because first column is, we have skipped already, we have already discussed this. The first column, computer knows that I have to save my flopping point, so that's why computer saves this first column, okay, to save it some flopping points. Now how many columns are there? There are n columns. Okay, there are n columns. So we have to multiply this minus 2 minus 2 1 with this entry, so and also with this entry, also with this entry, also with this entry, and also with this entry. So after multiplying this entry, so how many multiplication did we use here? We use here n multiplications, okay, with these n elements. Then how many additions we have to use when multiplying this guy with this one? We have to use this element with this element. Also we have to, after multiplying minus a to 1, we have to add with this element. After multiplying minus 2 a to 1, we have to add with this element. After multiplying minus a to 1, we have to add with this element. Similarly with this element. So how many additions we will use here? Obviously, because we have used n multiplications, because there are n elements, so we are adding with n elements similarly. Okay, so how many multiplications we needed here? We needed here n multiplications, and we needed here n additions. Okay, so in summarize, how many flopping points did we use here to make this this second row to be calculated? We need 2 n flopping points. Okay, n for addition and n for multiplication. Okay, so we needed 2 n flopping points to do this, right? But now come on this one. Okay, because we have introduced, we have calculated this row, so we needed what? 2n 2n flopping points. But how many such rows are there? Because we have to introduce 0 also here. So in this case, what we will do? We will multiply minus a, for example, third row, first column. We will multiply with R1, then add with R3. Okay. So in this way, we have to go all the way up to the last one. So how many such rows are there? Okay, how many such rows are there? You see, because first row we are not counting. Okay, first row we have already done. So how many times, how many remaining rows are there? There are remaining. So how many total rows are there below of first row? Because total number of rows are n. So below first row there are n minus 1 rows. Okay. So on every row we are applying 2n flopping points or flopping operation. So the total number of flopping operations that we required here are 2n and 2n into n minus 1. Okay, so total number of operation that we need to use to introduce 0 below the first column are 2n 2n into n minus 1. Okay, now I hope this is clear up to here. Next, continue in the second part of this video.